One of the things, if you notice, is our products, when we build the products which are related to a network operating system, like FTAS or ONCE or OPB, these are bottoms up because these depend on the platform, underlying platform, whether it is sonic or non-sonic. But when you look at Network Copilot, it is a top-down approach. That's how we looked at it, because it relies on the data, right? It doesn't matter from where it gets the data. It needs network data from on-prem or cloud, or if it is on-prem, it doesn't matter whether it is sonic or non-sonic. All it requires is the network data, right? So the moment you have the network data, what you do? We had a lot of operations we can do. We can do AML, we can do AOps, we can do NetOps, right? But then there's a huge amount of data. How do you process it? How do you make sure it will meet your use cases? That's where GenAI comes in, LLMs comes in, right? Because it has, we use the power of LLMs to harness this amount of data and created a product called Network Copilot, right? So even though on our side it says product, but actually we call it as a system, because if you look at GenAI, right, what do you need, right, to deploy a GenAI into your network infrastructure, right? It is a bunch of components or the modules which you need to enable GenAI. It is not just like a point product, you get it and do it, right? So that's what we looked at this when we built this Network Copilot product, right? We looked at it as a system. So starting with the benefits, we say that we go with LLMs. We want to go with open source LLMs because LLMs are growing very fast, and that's what we also saw. We started with OpenAI, then we moved on to Llama 2, and then now we are using Mistral 7B, and there is Gemma being released. We'll start using that, right? So the second thing is we want to make sure the system is robust, secure, and flexible. What do you mean by robust? It says make sure that it can be horizontally scalable, because the moment you start talking data, it's the scalability. That's the challenge you need to solve. So you need to make sure that the system can scale horizontally, number one, and it is secure, because data center infrastructure on-prem has to be secure. You cannot share a data from customer one to customer two. That's number two. The third one we looked at is the ease of integration, because the moment you say, okay, you're going to introduce a new product, it has to be less disruptive for customers. We cannot go ahead and say, okay, I'm going to deploy all these agents into your thing, and you need to reboot some of the services, or you need to reboot the switch from the on-prem perspective, right? So the idea here is the system introduce a way to ingest the data without disturbing the existing network infrastructure. How it works today, if you look at network infrastructure, any network infrastructure, on-prem or cloud, there are solutions which collects data. There are monitoring frameworks. There are capabilities which is built in already, right? We just need the data source. That is what we use as the data source, not the actual devices, so that it is less disruptive. And second thing is, we don't want to pull all the data, because today S&M pulls a bunch of OADs. We don't need all of them, because it depends upon what you want to build, use GenAI for, right? That's where this system introduces an easy integration into an existing network infrastructure, right? Fourth one, as I said, it's vendor agnostic, right? We don't we worry about only the data. If it is a simple fan speed, it doesn't matter where it comes from. It comes from Arista switches, or it comes from Cisco, or it comes from Sonic enabled switches. It doesn't matter. All we need is the fan speed. So it's vendor agnostic, number one. Vendor agnostic, not from the data source, but also from the deployment perspective of Network Copilot. What do you mean by that, right? Today, if you want customers to start with the need for GPUs, not everyone can get access to the GPUs, right? So you can start with inferencing on CPU itself. So basically, we have built the system in such a way that we have pre-trained the model, and you can do an inference on GPU as well as CPU, right? A lot of servers are available, and people can start using it. Finally, what the system gives you is a better TCO. First of all, you get open LLMs. Customers can choose from the open source. It's not like a proprietary solution. Second thing, vendor agnostic. Third one, they are not trying to hire a team to do it, because the system gives you the flexibility to get started right away, right? That is what we have. We are seeing Network Copilot are calling it as a system rather than a point product. Okay. So now, okay, now we have a system. Then we have now saying that what is it solving, right? That's the thing, right? So we started. It's a product requirement discussion, right? We started internally. We started picking to customers and all these things, right? So couple of use cases we came up with our own, meaning to say that we started with the first three or the standard use cases which we can use GenAI right away, because you have data for all these things. Okay. Starting with network compliance. What is network compliance? Network compliance can be as simple as saying that, is my network infrastructure running the latest firmware versions? Is my network infrastructure having the Linux versions which does not have any CVs, right? These are the simple complaints. Like it is focused towards a persona, right? Network complaints is focused towards IT team and also the NetOps, saying that making sure that my config or the spine layer or having the same ACLs or at the border are having the same ACLs to drop the traffic, right? These are the compliance use cases. Second thing is a very traditional one, which we said, the capacity planning and forecasting, which is a very, it looks like a prediction, but how will you predict without knowing the current utilization, right? So sometimes this is more focused for the network architecture team. The reason being is that because when you build a new network, when you expand your network, what do you look for? Okay, my applications are growing. How do you know your applications are growing, right? So you look at the utilization of the traffic, you look at the utilization of the ASIC, you look at the utilization of the routes you have in your network, right? But then, are you sure you want to go? Maybe you can solve this problem by opening up more ports in your switches rather than building them, or you can optimize by optimizing the ACMP load balancing algorithm at the compute itself to make sure that it has better load balancing capabilities, right? So that's the reason forecasting comes in rather than looking at the current utilization and making a decision which can really help that are we making the right choice to go expand. Third one is targeted towards NetOps, as it says, is troubleshooting, and also for the executive for business analytics, right? So this is very unique. Today, NetOps go at troubleshooting. They go back to various dashboards. They look at alerts and everything. But then, if you look at it, we have to simplify this with LLMs. That's what it is, right? You see an outage today. Okay, so you see an outage, then what do? You look for, okay, let me look at the counters where it is dropping. Then you look at, okay, what are the paths which are getting impacted, right? It's a step-by-step process, right? Yeah, there are tools today which can automate it and say that, okay, I can do it, but then how is it simple for it? You should use LLMs to make it much more simpler by asking a simple question, saying that, okay, what are the paths which got impacted by this outage? Then you say that what are the hardware SKUs and what was the reason? Was any services down, like BGP went down, or the link flap is continuously happening? Is it because of the outage? So you have to make it simpler in a conversational way. That's where LLMs come very handy for this. On-demand business analytics is something which, like, we create dashboards. A lot of people love dashboards. We have tables, we have a lot of software to do it. But then some of them may look, okay, I want to look at it in a different dimension than what you are showing me, right? So I want to build my own custom dashboard because I want to see when I present it to my executive team, they are interested only in certain factors. They are not interested in the whole operations, what you do, right? So that's the capability which we want to enable using LLMs to for the executives to make their own analytics dashboards, right? And the last one is very critical. Okay, the first three we discussed. We had a lot of discussion back and forth. We came up with this idea. Then we said, okay, this is all what we discussed in a room. And probably we spoke to a few customers who are doing some POCs and everything. But then the whole world is big, right? So every customer has their own problem, which they wanted to be solved in a different way. So that's where we said, okay, we should collaborate, right, and make the use case, because that is the power of unknown, right? Because that's what GenAI brings you, the capability to solve your problem on your own way and using the data set what you have, rather than going to getting a product and saying that, okay, this also, let me customize this and that and wait for the next release of the product, rather than build your own product, right? That's why we call it as a system again. It is not a product you solve a problem. Yes, it solves some of the use cases which we have built, but then you have an opportunity and you can do it very fast because the system is built in such a way, right? So how do we start, right? So this is a workflow or a life cycle, how we did it in our in Aviz when we build the product, and we believe this is the right way to get GenAI get started in any network infrastructure, right? It all starts with a business objective, right? Okay, what is your business objective? What are you trying to solve? Are you looking for any compliance? Are you looking for demand building some dashboards? Are you looking for any config generation for that matter, right? So what are you looking for, right? Then you look at data set, right? Is it the data is available, I just have to use it, or I have to make infrastructure changes to make the data available, right? And finally, how do I cost analysis? Is it really saying that, okay, I can see it with today, I can see something within 5 minutes, GenAI can get me down to 4 minutes? It's not useful. So you need to look at from the business objective what you are trying to solve, right? That's what we did, and we expect the same thing from the customer, right? Second thing, you have now you have identified the business use case and the data set, and you have to now get the data and start training. This is very critical for training because, first of all, you start with the model. you have to start with the model, you have to start with the base model. That's the number one thing, right? So when we started with OpenAI, right? Because that was easily available, APIs were available, we were able to do it, right? But as we made progress, we said, okay, this is good, but then it requires external internet access. On-prem data center does not like it, right? Because data is secure, you don't want to call an external API, right? So we started looking at, okay, how do we make a model which can be secure and resides within the data center, right? That's where we started. And the first line is very important. Import context. Import context is not a term here, it's a feature of the system. Because no matter how much data you have, you need to provide a context to say that what you're looking for from that data, right? Because from a simple inventory, somebody might be looking for what is my compliance for the firmware. Somebody might be looking for what are the hardwares which are going for end of life, right? The questions will be different, right? So you need to give a context, find out the context, what you are looking for, right? So, and then you start training the model. What do you mean by training? You take a base model, then you list down the things which you are looking for, the questions which needs to be answered, then you generate the SQL queries because everything goes back to the database, right? That is what the starting of the prompt engineering. That is how prompt engineering gets started, right? You have data, you have questions. Now I need to make sure that the model fetches the right data from the database rather than giving something, right? So now you go to the second stage where you have the data, you have the SQL queries and everything. Now the biggest questions today with the LLMs is hallucination. How do we avoid it? Right? Because yeah, you can train using reinforced learning via human feedback, continuous human feedback. That is a long time, right? That is one way to solve it. But then RAG came in, retrieval augmented generation. That's where the power of RAG comes in, the power of import context comes in, right? You have now two sets. One is the operational data, which is coming from the data center, which is stored in a database, which is streamlined, what you are looking for, cleaned up and everything. And then you have the context, which is imported into an embedding model, right? So now you have two of them. You use these two to tell LLM saying that give the response with less or probably zero hallucination. Accuracy is very important. That is where RAG comes in, and that RAG comes in. And even though your prompt engineering gets started at the previous phase, it gets better as you do the fine tuning with the RAG. And one more.
So I actually had a question specifically around RAG.
Yes.
So by using it to reduce the amount of hallucinations that you're seeing in the data that you're retrieving, does that completely eliminate hallucinations, or does it reduce it to the point where they're like a few, like 2 or 3 instead of 20 or 30?
So I'll tell you based on our experience, it is improving, but then it depends upon that amount of questions, because asking questions is like it's infinite, right? Anyone can, right? You have to attach to your use case, then it will reduce and completely reduce. Because when we started with this project, it used to give Python code to the point, right? When you say, right, you just ask a question, gives you Python code. Now we have improved it, and with the prompt engineering, which we do in-house, right? And that simplifies, that reduces the hallucination, and we are working towards, right? That's where. And one of the things you need to remember, these models are built for a lot of parameters. For example, Mistral itself is 7B, right? So if your data set is very small, you are not effectively using the model, right? It has to be like, then you cannot just say that, okay, I have data set small, I have 1,000 questions, then it will not give you the answer. It has to, you need to pick the right model and the right, for the right use case and the data sets, because that's where you reduce the hallucination. That is another way to reduce the hallucination. And also RAG gives you an advantage over that, because when you say import context, it is not just, okay, I just give some requirements here. You can feed anything. The framework, what RAG provides, like with Mistral, we use the framework for using ChromaDB and LangChain, right? You can import web URLs, you can import PDFs, you can import your own custom templates, everything, and pretty much make it more powerful. That's where the RAG approach gets us helpful, right? And then now we have a model which you are like 80% sure that, okay, it's ready for deployment, right? So you go for a deployment. So when you go for a deployment, you should have a very open mind, right? Because there are two things, right? When you go into deployment, one is on your pre-stage environment, the data set is less. Maybe you have tried probably 50% of what you see in the production. So you should be ready. You should be build the system that is horizontally scalable. When I say horizontally scalable, it is not just the GPUs, clustering of GPUs, but your services, which you run, you collect the data, you streamline the right. That should be distributed, right? Because you have to go with the microservices architecture. As simple as that. That's what it is. Because if you cannot do that, then you will get into the same scaling problem, right? So that's number one. Second thing is The second point is very important: dynamic user-defined objectives, right? So let's say today you started with a simple compliance requirement saying that my latency for today certain application is X. Tomorrow your objective changes because your network is growing. There are feedback from customers and saying that okay, it has to be much better. So your requirements changes, right? So it should be able to accept user-defined objectives. Like the requirement changes, the business requirement should be able to import it. Number one. Second thing is a new model comes. Today you are using a Mistral 7B. It's an open source model. You have the prompt engineering done on that model. Now a new model comes, which is much better. You should be able to opt to the new model because the reason being is two things. One is you have more data set now, which you want to train and everything. But then, and also the model is performing much better because it's growing. Because in the last 6 months, we have switched 4 models already with the lab what we have, right? And we are still evaluating more how to do it, right? And it's growing very fast. And same with the embedding model and the architecture, right? So that's, and of course then you put into deployment, you start continuously monitoring and retrain it, fine tune it again, and that's how the whole journey of Network Copilot starts for any customers. I'll pause here because it's an important slide. I'd like to wait for any questions. Yeah.
Question about the model selection. Is that just a process of trying to find what's best for your fine tuning, or you just needed to start over from a base? Like you said, moving from Mistral to something else.
Yes. So first, when we started, the GenAI, OpenAI was very predominant. We started with that. But then when we started putting our network data into it, right, the response, the accuracy of the data was not that great. Then we switched to Llama 2, right? So it comes down to your use case. That's what, again, that's where the collaboration is very important, right? If you are just have a standard use case, which this, most of the custom models which are available today, you can just download from Hugging Face, right? And one of the things you need to very carefully choosing the model is that how effectively it can generate the SQL queries, because that is one of the things that's very important. Because we have tried with the different models, that SQL queries is the key, because that's what the first step to reduce hallucination. Because you ask a question and you define a schema. By the way, one schema is very simple. You just return one select all query and get it, right? That's one thing. But in our thing, we have different use cases, we have different tables. When you want to do a correlation, the SQL query is very, very critical to get that, right? And after that, and it should connect to your context and do it. And another thing I must mention, we'll see there, the model should be able to come up with a newer architecture. I don't know whether you guys know, recently Google came back and said that, okay, you should start using the model to control your own agents. What does it mean, right? I'll tell you a classic example, what we faced, right? That's a live example, right? There was a POC happening right now as we speak in Japan. And one of the things where they were liking the answers, their use case was more towards NetOps. They were liking the answers, but then the answers were in English because most of the models are trained in English, right? So they're saying that, okay, it takes a long time for me to read it and then convert it, right? So can you guys provide a response in Japanese, right? So we started playing with it. Okay, what does it do, right? The questions were able to accept in Japanese, but the responses were still in English, right? But some of the responses came in Japanese, but some not, right? It is not the thing. Then this is where the new architecture comes, where you can build your own agent to meet your needs. What we did, we created our own service. Google calls it an agent, we call it as a service, wherein which these services can be controlled by the model. We just did a translator. That's what it is. LLM controls it and provides a thing. And same thing, we started building now the agents for each one of them. For example, custom on-demand business analytics, we have our own way because somebody likes the way quick site charts are there, and from Amazon, somebody likes the high charts, right? So you can custom design what agents you want to build. And then the third use case is the config generation. We have our own product, which is an orchestration product, open network interface suite once, for which we have a generated YAML file, right? But then right now we are focusing on trying to create an Ansible playbook from the model. So these are the GenAI is growing very fast, and where the innovations can happen very fast. That's what we see. And because this all happened in the past 2 months, saying that, okay, a new architecture comes in, and we are trying to align the system towards the new architecture so that we can help customers to meet their use cases. Okay. So this is a simplified version of our solution architecture, right? There are 2 blocks to it. On the left-hand side is the customer realm, we call it, is where we get the data from, right? And we have tried to keep it very simple, right? it doesn't matter whether it is on-prem or cloud, right? When we say network data, it is pure network data. It doesn't matter from where it comes. It comes from switches, it comes from routers, it comes from compute, or it comes from flow logs, or S-flow, or actual packets, right? So we use a standard. For example, for on-prem, we used SNMP because SNMP is predominantly still there, right? People say, but then we also support Arista IOS APIs, and we also support gRPC and our own agents, which is then. And for packet application visibility, we use S-flow and also raw packets, the way, right? And for the cloud, we use API. AWS provides a very nice CloudWatch API. We can pull it in. You can just put the data into an S3 bucket and just get it off, right? That's the simplest way to ingest the data, right? And then it goes into our ingestion pipeline. As you see that it's a cluster, right? It is not like a single ingestion pipeline you get choked. It's a cluster so that it can horizontally scale, right? And we then process the data, normalize it. When I see normalization, it means like removing noises, because that's one of the critical things, right? Some metrics may come as percentage from one vendor and as a RPM for fan speed can find as a RPM from another. So we need to normalize it to a single way so that you give the model the right instruction to do, right? We store in our own database, and by the way, this data store is something which we have as part of the service. But if the customer has their own database already hosted somewhere, we can write it there. All we need is access to it, right? And then this is on the operational data, whatever the data coming from the networks, right? So the RAG comes in as a separate thing. It's an embedding model. When we say embedding model, it's very important because it's a knowledge base. Because we are slowly building the knowledge base in ChromaDB in such a way that, for example, what we did right now, we are doing actually is for the CVEs, Linux, right? We are just pulling this and building the knowledge base into the embedding model because we don't want to pull it at the runtime from the customer side. End of life support for devices. How many devices? These are we are pulling from switch vendors website. And we are building the knowledge base ourselves, right? And then latest software versions, we are building the knowledge. But then this is what you have based on public materials which are available. But then what the customer needs is a separate thing. That's where the knowledge base is built from the customer, saying that we provide an API, an import context API, which can ingest this data, and this model it's a database which the LLM refers to for building the context, right? And then finally, we have the LLMs, the model. We are right now using Mistral Instruct 7B. That's the model we have for the last 2 months. We have been, it's getting good results. Gemma came out, but we haven't gone there because first we want to make sure that the system is good and all these agents, everything works fine. And we started building the agents on top of the models. And these agents are something like pseudo services which are controlled by the LLM. It is not like that the agents or instructing LLM. LLMs instruct the agents to do the stuff. That is the power, right? It's the other way around, right? So what it means is that these are our agents, but then if you have a tool in your own network infrastructure, let's say today you are using a networking infrastructure tool to generate a Ansible or even any configuration, you can attach to the LLM and say that, okay, generate me a Ansible playbook for a 2 IP clause with 8 leaves and 4 spines, right? It will generate. And of course, it will not fill you the IP address and everything. You have to do it. But then if you want to do that, then you have to give the actual intent topology, what you are trying to build, then it will do. Because that's where this architecture fits in very well. And finally, we have a API gateway. We can call it via an API and integrate, or we provide a simple chat prompt GUI where you can ask the questions and get the answers for it.
Question on the data store side, right? I may already be ingesting a lot of these data types into different areas, right? Maybe for some performance, maybe for configuration management. Can that be connected to Network Copilot, different data stores?
Yes. So we use 2 types of data store we use today. One is for point in time. Inventory doesn't change. You can just pull it once a day or probably once a week, right? Because nobody changes the switches like every day or something like that, right? That's a Postgres, right? For time scale, which is for time series, we use a time scale, which is the time point. It's not time. It's like we pull metrics. It varies. We do it we ingest every 20 seconds or something like that. If it's a real time, right? So it can be different, yes. And that's what I said. This data store cannot. This is what we use, by the way, in the system. But then, if the customer has S3 bucket, we just have to fetch it. You just need because all these data stores provides very nice external way to connect, right? For example, Kafka is very predominant. You can just use a Kafka bus and just connect to any database and get it done. Okay.
Yeah.
Okay. So I think we have time for the demo, I guess. So this demo, right? We want to cover the 4 use cases. First is the compliance use case, how we have built it, and this is our Copilot, by the way, running in our lab, and we created the video of it. If time permits, we'll show you a live session to it, right? And we'll show you what are the questions, because these questions are, by the way, we created as an engineering team, started creating what, right? And starts with the question, how can you help me? Because this is one engineer asked me saying that, okay, just tell me how can it help me, right? So that's how it starts, right? So it gives you what, and previously it used to give a big paragraph about a generic answer like ChatGPT. Now we have trained that, okay, it is more towards that. So you can ask a simple question saying that is my network compliant, right? It gives you an answer saying that, okay, today in our infrastructure, what we have put is we have put a few compliance requirements. You see the button here, import context. This is where the compliance requirements goes in. If we have our own template. So we have just to simulate it. We are saying that, okay, for my own data center, bandwidth should not exceed certain percentage, memory utilization of all the devices should not exceed certain percentage, right? So based on that context, it is giving you a response saying that, okay, we have 5 devices which is running, and on the average we have certain percentage of CPU utilization, and they are compliant or not compliant, right? Then you go down, okay, then you say, okay, this is saying, but are these my real compliant requirements? That's what you're asking. So then it will give you what are my current compliant requirements, basically, right? So it gives you, this is what you set it up. And then you go down further. Is there any non-compliance, right? If there are non-compliance, it will give you the device's queues and IP address, and you start. Now you are going down with the conversation. How you ask your team, you are asking the chatbot the questions, right? The second use case is more towards the on-demand business analytics, right? So this is for IT executives, right, who wants to build their own dashboard. So it gives you, we have, as you see, we have like 4 devices here. We have Arista, we have Cisco. I think there are 2 Sonic devices, and the first one is a Cumulus, by the way. So it's NOS agnostic. All we need is data. And the way we are collecting data from this without installing any agents to any of the other than Sonic. Sonic is our own agent anyway, because Sonic doesn't provide very good way to collect the data. So we have this, right? And then you're asking, okay, just draw me a pie chart. Then you are saying, okay, the NOS versions, these are running different SKUs. Then we read the NOS versions. Based on the NOS version, what are the NOS versions? How many percentage of that? This is for the compliance thing, saying that, okay, we should be having all the spine layer running 2.1. That's the expectation, right? You can say that, okay, if there are anything different. So this tells you Arista's 4.27, Cisco's 9.3, and Sonic, you have 2 different versions, right? This is a point in time. As to respond to your question, this is a point in time data, because it just doesn't change very fast, right? Now we are looking at the bandwidth utilization. Yep. So it gives you for the past 2 months. So one of the things you can see we are improving here is, as we see, right, the way it interfaces, right? We are trying to improve, saying that how we can give that. Right now, the way the model works is it pulls the data and emits it at one shot, right? The next step is to continuously give it when as it gets the data, right? These are the agents thing which comes in. You need to add the agent saying that, because this is the interface, right, which you want to have. Like, okay, I should just put a question. I should not wait for a certain time. I have to see the start typing the answer. These are the capabilities which can be added very fast, right? And using your proprietary agents. This is what I was mentioning, that we have integrated our once capability into this as an agent, saying that, okay, because our test team tests different topologies for simulation, they make mistakes in creating the YAML file. So we created an agent which they use it. Now it is integrated to the NCP, Network Copilot, where you can generate the YAML file and then you can fill in the necessary information. For example, right? You see, it is pretty much generating the template. and it defines that, okay, you asked for a 2 spine and 2 leaf, and I believe that you have connected it in a non-blocking way. Basically, there is no oversubscription, right? That is how it generates right now. But then these are additional fittings. You can say that, okay, it should be 2:1, right? The architecture, how we are building the architecture, generate the YAML for it, right? So that's where this plays in. And pretty much this is our whole intent, saying that what is the BGP I have to do, what are the IPs. It will not generate the actual IPs because it doesn't make sense, but it can do if you want to. The last one I mentioned is the troubleshooting. So you start with a simple question: are there any packet drops? Number one. Then you say, okay, how much percentage is actually the packet drop? This is very important because when you go into the data center, yeah, lot of links carry every traffic. You don't have to worry about packets which are bandwidth which is less than 10 Mbps because those are control plane traffic, right? You need to worry about the data traffic because that's how hyperscalers do their things, right? They don't worry about BGP packets. They don't consider that into the actual bandwidth utilization. So those are some of the things which we did in the model while training. Look for the traffic bandwidth utilization over a certain limit. Then you look at derive there is a packet drop or not. That's how you set the compliance there, right? And it gives you more details on each device, how much, and you see that there is one device which is having some drops, and then you are trying to now saying that, okay, what is you're going down, you're troubleshooting, right? What are the things you want to look for, right? That you are studying.
Question on the troubleshooting aspect of this. So we could focus on BGP. I've got somebody in there who's troubleshooting, and they're trying to figure out, this thing happened. How to phrase it? So how can I tell, like, a BGP session dropping is related to the issue I'm looking at? It's not a red herring.
Yeah.
Do I have to tell it that, or can it infer from the data?
It can infer. Good question, right? So first of all, how do you know BGP session is traveling? You did the neighbors flapping, number one, right? So now we have to see why it is causing. It is because of the control plane services, BGP protocol itself is low, or it is because of the link failure, right? So you have two data now, right? One is the BGP health, which is ingested, and then you have the link failure. I'm just taking two examples, and then you have the services status, health status of all your services running, like BGP, daemon, and everything, right? Now you start correlating these three, and you ask, because this is how we debug, right? So okay, this went down. Let me check whether there is any link flap around the same time manually, right? This can be done with the model itself. If you fine tune the model, it will correlate across databases and tell you. And you can ask. That's what I told you the outage thing, right? Is the outage happened because of my high CPU utilization, or the outage really happened because there is too much traffic coming in? Right. So it can correlate. Yes.
Okay.
Okay. I think we are almost like I'm just looking at the timer. Sorry. So one of the things I wanted to show is the live, right? This is the live thing, right? So this is what, right? We added the Japanese capability quickly, right? And when we say import context, it is a template. You can just choose a file and do it, right? These are some of the capabilities we have. And then, as I said, it's limitless. The innovations are limitless, right? We started looking at Ansible, like once is one thing which our own application which we control, but then Ansible is public, right? We can get it information. We started looking at, can you generate Ansible playbooks, right? So we have started now building the agents or the services which can be controlled by the model to make it more effective, solving the real problems rather than giving us a product to the customers use it, but then think, okay, solve the problem with GenAI. That is the whole idea behind creating a system rather than creating a product. That's it.